All right, so we're talking about 1.5, which is all about combinations of functions. Okay, so we have four of our arithmetic kind of functions that we can do. So the first one, what we can do is we can call it the sum. And in the sum, all we have is we have our two functions. We'll call them f of x, and we'll call it g of x. And so we're just adding our two functions together. This is also equivalent to putting the f and the g together and then saying of x. So either way can be written for the sum. Instead of sum, we can do difference. So instead of adding, we can subtract. So again, f of x minus our g of x, we take two functions and subtract. The biggest thing we have to remember over here is that the entire function is going to be subtracting, not just the first value of your function. And then we'll say f minus g of x. Okay. So we can add, we can subtract. What else can we do? We can also multiply. So we have our product. So product just means that we are going to multiply f of x by g of x. Okay, we don't necessarily need the little dot in between. We are assuming that is being multiplied, but you can keep it in there if you want to. And again, if we want, we can write it just like this, where f and g are together, and then of x. And then last but not least, if we can multiply, we can also divide. So we have our quotient. And so we're going to take our f of x, and we are going to divide our g of x. Now we have to be careful. When we put a function on the denominator, we have to remember that we cannot have our denominator equal to 0. So not only am I going to write it like this, where f and g of x is written like this, we also have to say that g of x cannot equal 0. So we want to also define sometimes our domain when we're talking about our combinations of functions. Okay, so let's get a little practice with these. So practice. Okay, so here are our two functions. F of x is equal to, and we'll say x squared plus x minus 1. We'll say g of x is equal to negative 3x plus 7. So if you want to pause the video right now, you can try these on your own if you want to. But we are going to attempt to do these problems. We're going to say f plus g of x. And then over here, we're going to say g of x minus f of x. And let's also multiply. So the third one will be f of x times g of x. So again, if you want to go ahead and you want to pause the video and try these on your own, be my guest. Okay, so hopefully you pause the video, you try these on your own. If not, we're going to walk through these together. So again, f of g of x. So I'm going to take my f of x first. So x squared plus x minus 1. And I'm just going to add my second function to it. So plus sign, negative 3x plus 7. Now the great thing about addition is that nothing needs to be distributed to either one. So we get to drop our parentheses. So plus negative 3x plus 7, and then combine like terms. So I just have x squared. I'm going to combine x and negative 3x. So I'll say minus 2x, and then combine negative 1 and that positive 7 to give you plus 6. And again, that's a 2. Let's make sure I write that better. And that's 2. Okay. Now, if we had changed the order, we still would have gotten the same answer. With subtraction, order does matter, okay? And again, parentheses are going to be very helpful here. So we're going to say negative 3x plus 7, okay? And then we're going to subtract, and this is why parentheses are important, because we want to subtract the whole function. We don't want to just subtract the x squared. So again, second step, we are going to distribute. So everything is going to become the opposite. And then collect the like terms. We always put in the highest order first. So this will be a negative x squared. And then I'm going to combine my x's, so minus 4x, and then combine the ones, so plus 8 as our answer. All right, last but not least, let's do multiplication. So I like to use the area model to set up my multiplication. You do not need to use the area model if you do not want to. So one side has 3, one side has 2. So this has a 3, so negative 3x, and then plus 7, and then x squared plus x minus 1. Change my color again. So this will become a minus 3x cubed. This will become a 7x squared, negative 3x squared, regular 7x, positive 3x, and a negative 7. Combine like terms, so I only have one of the x cubes. I got negative 3 and a 7, so this will be plus 4x squared. 7 and 3 gives you 10x, and then minus 7. Okay, so as I go through this, right, I want you to notice that this is a parabola and this is a line. When I combine these two functions together, right, I still get a parabola when we're adding or subtracting. And notice that my domain is still going to be all real numbers for every single one of these problems. Okay, this is a cubic and it's still going to be all real numbers. Okay, when I divide, right, that's when I'm going to run into some issues. So if I take the same values, so f of x is equal to, what did I say? X squared plus x minus 1, and then g of x was a negative 3x plus 7. Okay, and if I divide these two, so if I say f of x divided by g of x, okay, so I'm going to get x squared plus x minus 1, get negative 3x plus 7. X squared plus x minus 1 is not factorable, right? If we try to multiply numbers, there's no two numbers that I can multiply to negative 1 that are going to add to a positive 1, right? 1 and negative 1 are going to work, but it's going to add to a 0, so not factorable. So that means there's nothing else I can do with this problem. But notice what I did make myself have a denominator. So this does not have the domain now of all real numbers. Okay, so I would have to set my denominator equal to 0. So negative 3x is equal to negative 7. Divide by negative 3. So I get 7/3. So it's all real numbers except for 7/3. So I can either write it like this, negative infinity to 7/3, union it 7/3 to infinity, or I can say all real numbers except 7/3. Okay. So that is adding, subtracting, multiplying, and dividing our functions. Okay. What we can also do, we also have something known as the composition of functions. So composition of functions. And basically this is you are putting a function within a function. So putting a function within, within should be together, within a function. So if you think back to your integrated 1 and 2 classes, we had these function machines, right? So if we, let's pretend I can draw a function machine, right? Bam. So you're going to input an x value, right? And you're going to input it into this lovely function. And then out pops an answer. So out pops your f of x. And if I have another function machine lined up ready to go, I'm going to use this answer as now my new input into this new function. Okay, so it's a new function, call it g of x, and then out it's going to pop my answer. Okay, and I can keep going. So basically what I'm doing is I'm only plugging in my value in first to get an answer. Okay, so how we can read this in mathematical terms is we can say is that f of g, so fog of x. And what that looks like is we're saying that this is really f of g of x. Okay, so notice that the g of x is within the f of x. Okay, or vice versa, we can also say g of f of x, which then would be g of f of x. So again, the function f of x is inside g of x. This is the example that I drew, was the g of f. Okay, how we can read this is that it's read like this. It's read as f, so this one, f composed with g. Or we can say it this, f of g of x. Okay, I want to make this very clear, right? This is not the same as multiplication. Okay, not the same as multiplication. So f of g of x, fog of x, does not equal f of g times x, right? So notice that I am drawing a little circle there. Okay, so let me show you what I mean by this. So let's do two functions. So I'm going to say f of x is equal to 3x plus 1. And I'm going to say g of x is equal to x squared minus 2. Okay, and I want to know what is f of g of 2. Okay, so what this means is I'm going to plug in 2 into my first equation. Okay, so I'm going to plug it in right here. So I'm going to say that this is g of 2 is equal to 2 squared minus 2, which gives you 4 minus 2. I picked a wrong number. That's okay, of 2. And so what you're going to do, it just so happens that I picked a number that you're going to re-plug into this function. So then that means I'm going to plug in my new answer into here. So we're going to plug in that answer into my new function. So 3 times 2 plus 1. So this will be 6 plus 1, which will give me 7. So that means that this answer is 7. Now, it's not always going to work out that you'll get the same answer. So let's try it again. Change my color. Right, let's try f of g of negative 1. Oops. Take away that. Let me rewrite this a little bit better. So f of g of negative 1, close, close. So again, I'm going to take g of negative 1. So this will be negative 1 squared. I just realized I'm going to pick a different problem because it's going to give me the same answer. Let's change this from a negative to a positive. Make it very easy. Okay, so we're going to plug in 1. 1 squared minus 2. So 1 squared is 1, minus 2. And so this will give you negative 1. Right? So that means I'm going to use that answer to plug it in to my new function, f of negative 1. And I'm going to plug it into that function. So 3 times negative 1 plus 1. So negative 3 plus 1, which gives you negative 2. So this answer is negative 2. So essentially what you're doing, again, you're taking your function, right? And this is your first function, g of x. And then this is our second function, f of x. And whatever number you're going to plug in, so you're going to plug in some number, you're going to get an output of some number. You're going to use that number as your new input. Okay, so again, it's a composite function. Now, we can do this with numbers all day long. Okay, and we can switch it up. We can say we can put g of f of x, and it's going to change our whole output. Okay, sometimes we don't have a number here. Sometimes we have a letter. So let's still use the same values. Or actually, let's change it. Let's come up with new ones. So I'm going to say f of x is equal to, let's go with 1 over x. And we're going to say g of x is equal to 2x plus 1. Okay. So I'm going to try this first one. So I'm going to say f of g of -1. I want to figure out what this is. Okay, so I'm going to first plug in -1 into this equation. So g of -1, so 2 times -1 plus 1. So -2 plus 1 gives me -1. And then plug it back in to my f function. And I'm going to get 1 over -1, which ultimately gives me -1. I'm not very good at picking these numbers too. It just so happens that I'm randomly picking these numbers off the top of my head and it's end up giving me the same values. Let's try a different one. This one will not be the same. So f of g of 5. Okay, here we go. So g of 5 is equal to 2 times 5 plus 1. So 10 plus 1 gives you 11. And then I'm going to plug 11 in to this new function. So 1 over 11. Can't do anything with that. So this is just going to be 1 over 11. So ultimately, now we could keep doing this until the cows come home with different numbers, right? But sometimes it's easier to come up with a new function. So when I come up with a new function, I can just say f of g of x. So basically what this is saying is I'm going to plug an x into my g function. Well, guess what? The x is already plugged into the g function. So this just is 2x plus 1. If this is confusing, you can always change this x to, say, an a or a different letter. So now again, here's my whole output. There's nothing else I can do. I'm going to re-plug in this guy, right? So this guy is now plugging into my new function right there. So this is just 1 over and then 2x plus 1. So I should be able to say this, that these f of g of x is equal to 1 over 2x plus 1, right? So that means I should be able to plug a 5 into this, and it just immediately will give me the 1 over 11, right? So if I plug a 5 in, so this will just be, oops, let me write the rest of this. There we go. So this will be 1 over 2 times 5 plus 1. 2 plus 5 is 10. 10 plus 1 gives me 11. No, it's the same answer. So we can always double check our values. Now notice that our domain did change, right? Notice that on this function, the domain cannot be equal to 0. But when I write my f of g of x is equal to this function, right, my domain is going to change, okay? So my new domain on this composite function, right, I'm going to set 2x plus 1 equal to 0. So 2x is equal to -1. X is equal to -1/2. So that means it's all real numbers, not including, right, -1/2. Again, I can say all real numbers except -1/2. Whereas our beginning was just 0. So when you do composite function, it does change our domain. Right? Let's try one more with that kind of in the back of our head. So here's our new function. Let's go f of x is equal to, let's go radical of x, right? Feeling kooky with that. And then let's go g of x is equal to x squared minus 1. Okay, so we are going to find fog of x and the domain. Okay, so I want you to notice that this domain is a parabola. It's all real numbers. This domain is a radical. 0 is not going to work. What's going to happen when I put a function within a function? So I'm going to take this function g of x, right? And I'm going to plug it in right there, right? So this will look like this. F of, let me change my color, x squared minus 1 is equal to the radical, and now I get to plug in the new guy, x squared minus 1. Okay. So now when there's no way I can simplify this. This is a difference of two squares, but it's the radical is not going to be able to change. So my answer is complete. Fog of x is just equal to the radical of x squared minus 1. But now I want to figure out what my domain is. All right, so the first thing I'm going to do is I'm going to set this equal to 0. So I'm going to get x squared is equal to 1. Take the square root of this. I'm going to get plus or minus negative 1. Okay, so now I got to figure out what numbers are going to work, right? It's not in the denominator, so 1 can be included in my numbers. So I'm going to quickly make a little table. So I have 1, I have 0, negative 1. Let's try 2 and a negative 2. All right, so first 1 is going to work. 1 squared minus 1. This will give me 1 minus 1, which gives me 0. So this is going to work. All right, I get an actual number. I can take the square root of 0. All right, let's try 0. 0 minus 1 gives me the square root of negative 1. That doesn't work. Okay. If I make this a negative 1, that is still going to work. Fantastic. All right, let's try 2. So 2 squared minus 1. So this will be 4 minus 1, which is the radical of 3. That does have an answer, so that's going to work. If I make this negative, right, again, I'm squaring the negative part. That still turns out to be positive. So it looks like it's every number except for the numbers in between 1 and negative 1. Now, I'm not trying out the 1/2, but 1/2 squared is 1/4, and 1/4 minus 1 is not going to work. So my answer, here's my equation. So when I want to find my domain is going to be negative infinity all the way to 1, or negative 1, I should say. That's a smaller number. And then I'm going to jump to a positive 1. Okay, so I'm skipping every single number that is not included with the negative 1 to 1. I'll show you what this looks like in the graph so we can kind of use a graph to make sense of this. So again, 0 is not included. 0 is still not included, right? But 0 was the only number. It was 0 and above, right? So now if we look at our graph, this is what the radical of x squared minus 1 looks like. So notice that there is a gap in between these two numbers. Okay, and that's all composite functions are. Okay, so again, function within a function. So we talked about two things today. The first thing is, can we add, subtract, multiply, and divide functions together, right? This is the basics of arithmetic. And then we talked about the composition of functions, so a function within a function, right? Again, I'm going to plug in a number. I'm going to use that answer to plug it into the second one. And the biggest thing to remember is that it's not multiplication. All right. If you have any questions or concerns, please email me so I can help you out.